to have reinforced knowledge about this topic. Okay? Kaya ganun yung nangyari. Okay? So, parehas sila at first para sure na magigets talaga. Okay? And also, with regards to your quizzes na I already published the scores. Okay? So far, everyone's score is okay naman. The typical average for the quizzes ay around 11. So 11 divided by 15 is 73%. No? Okay. So yun naman yung common grades ninyo. But if you missed the quiz uli, I'll be making one next week. Okay. So gagawa na lang ako ng quiz next week, which I will schedule no. Siguro mga Thursday to until midterm consultation. Okay? So, yun. So, abang na lang kayo sa gagawin kong makeup quiz. Okay? Pero kung kayo, meron na kayong quiz, yun na yan, as is na siya. Do not forget also that contributing to our discussion board will give you maximum of 5 points to be added to your quiz. Okay? So, onti pa lang halos yung nagko-contribute sa discussion board. So, pwede naman kahit ano na lang ilagay nyo doon, insight or questions. No? Okay. And then, I will dedicate one recording answering all those questions. No? Okay. So, siguro next week ko na lang gawin yan. Okay. So, yun lang. So, do not forget to answer the discussion board. Okay. That will be open until tomorrow. Same with the problem set. You will submit it until tomorrow. No? And again, for those who missed the quizzes, I'll publish another set of quizzes by next week. Okay? So I'll just look for questions na lang. And then, ayun. Okay? So, ganun lang naman. Okay tayo dyan? Yes, Nathan. Nathan. Naka-mute ka pa rin, Nathan, ha? Ito. I cannot reopen it anymore, pero gagawa ako ng panibago. Okay? Kasi yung na-reopen ko, nakapost na rin yung answers eh. So baka mamaya lumabas ulit. No? So gagawa na lang ako ng panibagong set. No? Don't worry. Same ano pa rin, same coverage. No? So gagawa na lang ako panibago next week. No? So I will just look for the questions and probably I'll post it no? Next week. No? So yun. So kung marami kayong na-miss na quiz, medyo marami kayong i-make up. For the problem set, it will still be open till tomorrow. Okay, so until tomorrow lang siya. Okay, kasi medyo matagal na rin yung time na nabigay ko na for the problem set. Ayan. So that pagdating ng midterm week, that's the time I will check the assignment. I will check them. Regarding po sa discussion board, kasama na po yung grade. Hindi pa sila kasama. Parang separate pa yung discussion board. No? So, kunwari, nag-contribute kayo dun sa 5 discussion board. No? So, i-add ko na lang sila sa overall, no? Sa quiz. No? Hindi ko siya ilalagay sa specific quiz, kundi sa total, di ba? Kunwari, total ng quiz 1 to 4 plus yung nasa discussion board. No? Don't worry, in the email, in the grade consultation naman, 'di ba? Alam niyo naman siguro last semester. In the grade consultation, I detail how your grades are calculated, no? So, doon makikita niyo kung saan mapupunta yung bonus points. Okay? So, yan. So, yung pag-add ng bonus points, separate pa siya doon sa current score niyo, no? So, raw score pa lang yan. Okay? Ayan. Also, when it comes to the lecture, matataas naman yung average score. Okay. Pero tignan ko pa kung magbibigay ako ng ng bonus points, no? So that's why it is really highly suggested you submit the problem set, no? So that I can project your grades. And then tignan ko kapag onti lang yung A, doon ako magbibigay ng ng bonus points, no? So yan. So kapag napasa niyo na yung problem set by Saturday, then probably I can start projecting what your grades would be, no? And if onti lang yung makakuha ng A, then probably I'll give bonus questions to everyone. Okay. Para naman tumaas uli yung percentage natin. Okay? And again, I will send you an email with the detailed calculation on how your midterm grade will be obtained. Okay? Bigyan ko lang kayo ng idea how does it look like. Okay. So, midterm consultation. Okay. So, kunwari, eto. Ayan. Sino kaya pwede? O, kunwari, ito na lang si Joshua. Biochemistry naman to. Okay. For example, kay Joshua, ayan. So, ganyan yung mga nare-receive nyo. Okay? So, isa-show ko rin yung mga adjustments na. Ayan. Something like that. This is from MedTech. Ganun din. Ayan. Okay? So, ayan. Even yung adjustments. Okay? So, ganyan yung gagawin ko. Okay? So, that is to ensure na at least maganda yung curve ng grades natin. Okay? So again, just a final reminder, if you miss the quizzes, I will make another one. I'll probably post it next week. Okay? Mga Thursday na. Kasi I still have to look for additional questions. And then for the problem set, they are all due by March 19. Okay? Kasi the deadline was pushed a lot of times na. Okay, so this is the last day talaga. So that by next week I can check them and I can decide whether to give you bonus questions pa or okay na yung grades niya. Okay? So, titignan ko yung projection ng grades niya. And then probably by March 31, I'll send you an email of your grades. Okay? And then in case you wish to clarify further, then we can have discussions, no? Okay, during the midterm consultation. And then by April 4, okay, continuation to ng chapter 5. Okay, so also chapter 5 is not going to be included in the midterms. The reason why we're going to discuss it lang is because we want to do something within this time. Okay, na-extend kasi yung midterm eh. So at least kahit pa paano may gagawin tayo. Okay, so this will not be included in the it will not be included in the what do you call this midterm exam, na. Okay, so just for the sake lang na may makover tayo in this extra week. Okay, so yan, I guess we can start na. Sige. Okay, so just to give you an idea, no, that this chapter overlaps the topic that will be discussed in your laboratory, no. Actually, patapos na nga kami sa laboratory. Okay. So, yan. So, almost half na kami doon sa laboratory. Okay. So, why is that, no? Bakit kaya parehas yung lecture and lab, no? Just to give you reinforcement, okay, especially when it comes to titration, because this is kind of complicated, no? And it really needs thorough discussion, especially when it comes to the equation. Why is the equation that, no? So, bakit kaya naging ganun yung equation? So, basically, yun yung gagawin natin today. Okay. However, the lecture topic will start to deviate with the lab, no, at the end, no. Kasi for the lecture, the last topic here will be the polyprotic, but in the laboratory, the last topic there will be the indicators, the titration of mixtures. No? So magkahiwalay na doon sa dulo. Okay. So only the first part will be the same so that we can have more reinforcements. Okay. So, yun, if you had your laboratory discussion already, so you have an idea on what we're going to talk about. So, basically, parang review lang uli ito. Okay? So, yun. So, for us to get started, let's talk about titration overview muna. Okay? So, we know that titration is a volumetric analysis, meaning that we are reacting liquids. Okay? Kapag volumetric, edi liquids yung ginagamit mo doon. And you use calibrated glasswares, no? When I say calibrated, sila may mga graduation or may mga markings. No? Okay? So the purpose of the markings or the graduations, sila yung nagtetel kung gaano karami yung volume na na-dispense, right? Okay? So, ayun. And then, those liquids that you combine, they will react with each other to form the products that is desired now. Okay. So, we have four types of titration. If you can still remember chapter 4. So, apat yung types ng titration. You have the acid-base, complexometric, precipitation, and the redox. No? So, pag BS Chem ka, lahat i-discuss yan. But just for the simplicity of this course, we're just talking about the acid-base titration or the neutralization titration. Okay? So, ito lang yung di-discuss natin. And now, what happens when you react an acid and a base? Ano yung na-form natin? Pag pinaghalo yung acid, pati yung base, ano yung nabubuo? Anyone? When you react acids and bases, what forms? Okay, nagiging neutral yung ating reaction, yes. Pero ano yung chemicals na product niya? Okay. So other than nagiging neutral ang solution, ang products na nabubuo ay yung HNOH, they will form the water, and ano pa yung isa? Starts with letter S. Okay. So yung acid and yung base, pag pinagsama sila, mag-form ng water from the H and the OH plus ano yung letter S na yan? Ayan. Wordle tayo. Kasi 4 letters lang. Ano kaya to? Letter S, 4 letters. And then, may letter A dyan. Okay. Yan. Salt. Okay. So, yan. Okay. So, just remember that when we are doing neutralization titration, we are forming water and the salt. Okay. So, yun yung always end product natin. Okay. So, yan. Yung water, of course, it is neutral. Okay. And then yung salt, okay, most of the time it is neutral as well. Okay. So, yan. And how do we do titration? So, in doing titration analysis, basically, you just add your titrant to your analyte. No? So, when you say titrant, this is a solution with known concentration, and the analyte is the one without known concentration. So, di mo alam yung dami ng analyte, pero yung titrant alam mo. Okay? So, what you'll do is you mix them. Okay? Ipapatak mo yung titrant dito sa ating solution. So, patak-patak siya until you see a color change. No? So, the color change is brought about by adding your indicator. No? So, commonly, phenolphthalein ang ginagamit. No? But there are also other types of indicator that we use in the chemistry laboratory. Okay? So, kapag phenolphthalein ginamit mo, the solution turns pink. Okay? And kapag siya ay naging pink na, so tapos na yung reaction. Okay? So, yun. Okay. So, that's the titration process. You add your titrant to the analyte. How much? So, depende kung gaano karami until you reach the color change. Okay? Or the endpoint. Okay? So, this is just the slide I got from the previous chapter. So, basically, these are the terms that you have to remember again. So, when you say analyte, sila yung unknown. They don't have known concentration, or sometimes the identity is not known as well. When we say identity, we are actually pertaining to the molar mass. No? And in the previous chapter discussion, di ba, may calculation ako doon ng molar mass. No? Okay? So, ganun. By the way, yung video discussion doon nasa announcement ha. So, I posted that last March 7 pa. Okay. So, yun. Kasi may iba daw na hindi pa nakikita. Nasa announcement since March 7. So, it's been 11 days na nandun siya. So, yun yung analyte. It doesn't have known concentration, or sometimes the identity is not known. Okay? And the analyte, and the titrant, ito yung alam naman natin. Okay? So, this is yung known concentration. Indicators, ito yung mga nagbabago ng kulay. Okay? They change color as we reach the endpoint. Okay? When we say endpoint, it is an estimate of the equivalence point. No? Okay, so kumbaga ito yung range kung nasaan yung equivalence point. Okay, which means the reaction is complete around that area. Okay, so yun lang. This is the video that we watched in the previous chapter, so I will not play it again. Okay, basta the idea lang is that this video shows us how titration is done. No? And sadly, we cannot do titration because, nasa bahay tayo. Okay. So yun, there are chemicals that are necessary kasi in carrying out titrations. Okay, na impossible makuha sa bahay, no? So yun, so we just need to watch this na lang. Okay? Pero in the previous chapter napanood na naman natin yan. Okay? So anyway, let's focus on the calculation part now. What's new with this chapter? So ano meron sa chapter na to? Kasi, di ba, sa previous chapter, nag-calculation na rin tayo. So, what to expect this time? In the previous chapter, ang ginagawa natin is nagko-compute tayo ng endpoint, pati ng mga molarity, pati ng molar mass, di ba? So, yun yung mga pinagagawa natin last chapter. So, either we calculate the endpoint, the molarity, or the molar mass. For this chapter, ang focus natin is to get the pH. Okay? So, yung acid, yung base, iba-iba yung pH niyan. For example, acids, they have very low pH. For bases, they have very high pH. Diba, i-combine natin silang dalawa in the titration. So, as we combine those two liquids, what will be the changes in the pH? So, yun yung i-monitor natin. And based on the previous discussions on the lecture and the laboratory, sobrang daming equation na gumagamit ng pH, di ba? Okay? So for you to be guided, you have to remember the following muna before we proceed with the calculations later. So always remember that when you have an acid conjugate base pair or a base conjugate acid pair, you need to use the Henderson-Hasselbalch equation. Okay? So, ano yung acid conjugate base? Ito yung nasa definition ni Bronsted-Lowry. No? So, you may want to revisit the laboratory discussion on that. Okay? Ito rin yung tinatawag nating buffer solution. Okay? So, ayan. No? So, lagi tandaan kapag may acid conjugate base pair or base conjugate acid pair, you need to use the Henderson-Hasselbalch equation. Another thing to keep in mind is that when you add your acid, nababawasan yung base. And kapag naglagay ka naman ng base, nababawasan yung acid. So, bakit? No? Because of course, we know na may reaction between them. Okay? Yan, sabi ko nga, di ba? The reaction of acid and base produces water and the salt, di ba? Okay? So, ganun yung reason, no? Kasi, both of them reacts to one another. Sabi sabihin, mababawasan talaga yung isa sa kanila kasi they will form the product. Okay? So, pag naglagay ng acid, mababawasan yung base. Consequently, pag naglagay ng base, mababawasan yung acid. Okay? So, bakit? Kasi nga, we are forming products here. Another thing to keep in mind is that when you add the liquids, syempre liquid yung ating titrant pati analyte. So if you add liquids, what happens is that the volume increases. And then as the volume increases, we know that it is accompanied by dilution. Okay? So, ibig sabihin, gagamitin din natin yung dilution equations later. And then most importantly, if you're dealing with weak acids or weak bases, you know, they are going to use equilibrium calculations talaga. Okay? So, may equilibrium calculation tayo later. Okay? So, yan yung mga kailangan natin tandaan. So, those are the topics discussed in previous chapters, such as chapter 2 in the lecture, and then chapter 4 in the laboratory. Okay? So, saan yung chapter 4 sa lab? Ito yon, yung Henderson-Hasselbalch. Itong addition of acid decreases the amount of base, etc. Ito naman, chapter 2 ng lecture. So, yung dilution. Itong equilibrium calculation naman, ito yung chapter 3 sa lecture, pati chapter 4 sa laboratory. Okay? So, you need to review them so that madali na lang itong topic na to. Okay? And so far, based on your quiz scores, okay naman sila. Diba? So, okay naman yung quiz scores. Kaya, I think okay naman lahat. Okay? So, just to summarize everything, so these are the equation that we need to use. I'll just edit this one. Okay, so hindi yan ganyan. Ito, typo ko na to last year pa eh. Okay? So, for stoichiometry calculation, ito yung equivalence ng moles, no? So, meaning at equivalence point, so meaning at the when the reaction is complete, the mole of the titrant is equivalent to the mole of the analyte, okay? And then we will multiply the stoichiometric factor. Mole analyte, y mole titrant, okay? So parang nag-convert ka lang dito, no? So it's it came from the stoich. Okay. So if you can recall the chapter 4 video discussion natin doon, asynchronous 'yon. Ginagamit ko tong equation na to in determining the endpoint volumes, di ba? Or even the endpoint molarities. Okay? So, yan yung ginagamit natin. Pag sinabing stoich, yan yung gagamitin. For dilution naman, recall that's MIVI equals MFVF. Okay? For the equilibrium calculation, so itong tatlo yung important. Okay, so Ka Kb equals 1 times 10 raised to negative 14. So that's Kw. Saan yan? Sa laboratory yan ng yun sa water. Okay, ion product of water. And then yung square root of Chaka. So if you watch the asynchronous video sa laboratory, which I made, okay, so diniscuss ko doon what does that mean, no? So that came from the small x approximation lang, okay? And in the base form, that's square root of CbKb, okay? So yung acid, that's square root of Chaka, concentration of acid times the Ka. Pero kapag yan ay base, that's the concentration of base times Kb, okay? And then, most importantly, yung buffer equation natin. So, Henderson-Hasselbalch equation yan. So, that's pH equals pKa plus log conjugate base over the acid. Okay? We also have the base form of this one. So that's POH equals PKB plus logarithm conjugate acid divided by the base. Okay? So, ito yung base form niya. So, kailangan tandaan nyo sila, ha? Okay? Yes, Nathan.
Sir, do we use the moles in this equation, or do we use what the given po?
Saan? Sa buffer?
Yes po, sir.
Um, Actually, di ba, nakwento na rin siguro to sa lab, na? Kasi the molarities here, no? So, remember, naka-fraction yan. So, this should be in molarity, di ba? So, that's moles over volume. Same as this one. So, moles over volume. Because same lang yung volume natin, so we can actually reduce it into moles na lang. Okay? Kasi parehas yung denominator nila na volume total. Okay? Kung nandun na kayo sa part na yun sa laboratory, sinabi ko rin yun sa class ko eh. Kasi the equation for this one is mole over volume total. For this one, it's also mole over volume total. So actually, kahit di ka na mag-molarity, pwede yung moles na lang because if you divide the two, the volume total will just cancel out. Ayan. So, kung given sa inyo yung moles, gamitin nyo yun. If given sa inyo yung molarity, okay lang din naman. Okay? Because the volumes will tend to cancel out eventually. Okay? Andun na ba kayo sa laboratory na yan? Okay, kasi sa amin sa lab, natapos na namin to eh. Okay. So, yan. Okay? So again, in the buffer calculation, you can use either the concentration or the moles. Okay lang naman, okay? Kasi the volume gets canceled out, no, during the calculation process. Okay? So dito din natin pwede i-apply yung pag nagdagdag ka ng base, nababawasan yung acid. Pag nagdagdag ka ng acid, nababawasan yung base. Okay? So, if you recall one of the videos sa asynchronous sa lab na ginawa ko, sinabi ko yun doon. Okay? So, nung naglagay ng acid sa ammonia, nabawasan yung ammonia, nadagdagan yung ammonium ions. Okay? So, watch the video na lang if you haven't watched it yet. Okay? So, yun lang. So, those are the equation and later on, sila yung kukunan natin ng derivation so that we can make equations specific for different types of monoprotic titration. Okay? So, ang acid-base titration or neutralization titration, maraming version yan. So, you have the monoprotic and the polyprotic. Okay? Let's focus first on the polyprotic because this is the simplest. Okay? Why it is the simplest? Because the moles of the analyte and the titrant will be just 1. Okay? So, 1 to 1 yung ratio lang nila. Kaya nga monoprotic, no? So, mono meaning 1, protic meaning hydronium ion. So, the acid will give 1 proton and the base will accept that proton. So, 1 to 1 lang yung ratio nila. Okay? And actually, there are 4 types of monoprotic titration. So, hindi ko pa ito na-update. Last year pa ito eh. Yan. So, there are 4 subcategories under monoprotic titration. So, we have the strong acid, strong base titration. And then the counterpart of that one, strong base, strong acid. And then we have the weak acid, strong base, and the weak base, strong acid. No? So all this can be abbreviated, no? As this one will become SASB. Okay, so this one naman will be SBSA. This one will be abbreviated as WASB. And then this one will be abbreviated as WBSA. Okay? So i-abbreviate natin kasi ang haba-haba ng terms. Okay. So what does that what does this abbreviation means, no? Kung ano yung unang sinabi na chemical, yun yung analyte, okay? So meaning, so for the SASB, the analyte is the SA, the strong acid, and the titrant will be the one that will follow. Okay? So, analyte, strong acid, titrant, strong base. So, yan. Kung sino yung nauna, siya yung analyte. So, for SBSA, ang analyte natin ay strong base, ang titrant natin ay strong acid. For WASB, the analyte is the weak acid, the titrant is the strong base. And then for WBSA, the analyte is the weak base, the titrant is strong acid. What can you notice, no? Manonotice nyo that the titrant needs to be strong parate. Because yun yung qualifications for the titrant, no? It cannot be a weak acid nor a weak base. Rather, titrants must always be strong. Kasi in the previous chapter discussion, nasabi ko doon that the titrants should completely react to the analyte. Okay? So, hindi pwedeng weak na titrant na. So, kailangan strong talaga sila. Yes, Nathan.
Why in the strong acid and strong base titration? Why is the base the titration unless it can be both or
Ano yan? Bakit both strong acid? Ay, strong?
why is the strong base the titration if when both of them are strong, sir?
Can you clarify further? Ano pa? More context pa.
Both are strong in the strong acid and strong base. So how do we know if one of them is the titration, sir?
So, how will you know if sino yung i-react?
The titration, yes, sir.
Sige. With regards to that, no, para malaman natin yung type of titration, later in the examples, I will show you how will you know if SASB sila or SBSA. Okay, kung sino yung analyte, sino yung titrant. So it actually depends on the order on how the chemicals will be stated in the problem. Okay, kung sino yung nauna sabihin, that is usually the analyte, no? That is in the Erlenmeyer flask. And then the one that will follow will be your titrant. Okay, so later, let's contextualize those terms later na sa ating calculations. Okay? So, yan. So, just keep in mind that for now, the titrants must be strong. Okay? Yung iyong analyte, it could be strong, it could be weak. But for the titrant, it is required for it to be strong. Okay? Kasi we want the reaction to be complete. Okay? Also, if you are thinking, bakit kaya walang WA, WB? Okay? Walang weak acid, weak base, or weak base, weak acid. Hindi pwede yan. Okay? Because, parehas silang weak. So, how will they react? Okay? So, at least there should be one strong chemical, okay, for the reaction to happen. So, it is not possible for them to be both weak. Okay? So, kaya at least one of them should be strong. Okay? So, kaya may mga SASB, SBSA, WASB, WBSA. So, kailangan may strong dyan kahit isa. Most importantly, the titrant. Okay? So, pag yung titrant mo ay weak, walang mangyayari. Okay? So, para ka na naghahalo ng toyo pati ng suka. So, walang mangyayaring reaction. Okay? So, yan. Okay, so later let's contextualize how you will know kung anong type ng reaction yan. Okay. So basically, whichever was stated first, yun yung magiging analyte mo. Okay? So, ayun. For every types of titration, we have different sets of equation. So, it is really important for you to know anong type ng titration ba gagawin mo. Okay? Kasi we have the equations for SASB, we have the equations for SBSA, we have the equations for WASB, and then we have another set of equation for WBSA. So, ang dami niyang versions. No? So, I don't know kung nasa na kayo sa lab, pero lahat ng yan i-discuss naman. Okay? So, yeah. So, for every types of titration, there are 4 equations that we need to use. So, bali 4 times 4, 16 equations yung may gagamit natin. And you have to be very careful which you should use, no? So, again, sabi ko nga, so yung type of titration depends on what was stated in the problem. Okay? Kung ano yung sinabi sa problem na chemicals, then you can infer which type of titration you are doing. Okay? So, for example, bigyan ko lang kayo ng example dito. For example, sinabi dito, 50 ml of 0.05 molar HCl with 0.1 molar NaO. Okay? So, you know that HCl is a strong acid, no? Okay? So, nasa chapter 4 yan sa lab, no? So, this is a strong acid, no? And then the NaO is a strong base. So, anong type ng titration yan? SASB. Okay? So, for SASB, these are the equations that you need to use. Okay? What if ganito naman yung problem? Okay? So, for example, sabi dito, so you have acetic acid with sodium hydroxide. So, the acetic acid is a weak acid, no? Okay, na-explain na yan in the laboratory. Okay, basta may Ka, weak acid yan. Okay? And the sodium hydroxide is, of course, a strong base. So, what titration you have here? WASB. Okay? So, ayun, the type of the titration depends on what chemical was given to you. Okay? So, ibig sabihin, you should have a working knowledge on the strengths of acids. Na? So, yeah. Another example will be this one. Okay? Sodium cyanide with hydrochloric acid. So, sodium cyanide, this is a weak base. Okay? So, this is a weak base. Okay, paano ko nalaman na weak base? Kasi given yung Kb. Okay, ganun lang yan. Pag given yung Ka, that's a weak acid. Pag given yung Kb, that's a weak base. Okay? And HCl is a strong acid, no? So, what titration you have here? WbSA. Okay? So, yan. So, you have to contextualize your equation depending on what are the chemicals given, no? Kung ano yung mga binigay na chemicals. Because if you use the wrong set of equation, ibig sabihin, mali yung masusolve ng sagot. Okay? And dun maraming nagkamali na, nung last year sa titration. Actually, nagkamali lang naman sila sa conversion ng POH to pH. Okay. So, dun lang sila nagkabaliktad. Kalimutan nila i-convert yung POH to pH. Okay? So, pero there are some na nagkamali ng identification ng types of ng subcategory ng monoprotic titration. Okay? So, basta tandaan natin that whichever was stated first in the problem, that will be your analyte, and whichever goes next will be your titrant. And the titrant should always be a strong chemical. Okay? Yung analyte, pwede siyang strong, pwede siyang weak. But for the titrant, it should always be strong. Kasi if it is not strong, then there will be no chemical reactions. So, meaning wala tayong weak acid, weak base, nor weak base, weak acid. So, walang ganun. Okay? So, let's check yung previous na na-discuss sa inyo in the laboratory if nag-discuss na kayo. Kasi sa amin natapos na namin eh. Kung gusto niyo ng video, I can give you a copy naman. Okay? So, yan. So, for strong acid, strong base titration, again, just as I mentioned, whichever comes first will be your analyte. And then, kung sino yung susunod, yun yung titrant. Okay? So, SASB. Acid is the analyte, base is the titrant. Okay? So, this will be my general question to everyone. So your analyte is the acid, no? What is the pH of an acid? Is it greater than 7 or below 7? What's the pH of the acid ba? Is it greater than 7 or below 7? Ano sagot niya dun? Okay, it's in chapter 4. Below 7. Okay? So, meaning that in the titration process, you will begin with a very low pH and then gradually it will go up. Na? So, mababa muna pH mo and then tataas siya as you add your titrant. Bakit siya tataas? Kasi nga, you are adding a base. And you know, bases have high pH. So, start ka muna sa mababang pH and then as you add your titrant, it will go up. If you graph that, it will look like this. No? So, this is your initial pH and then upon the addition of your titrant, the pH will start to rise. Okay. Ayan. So, the pH will start to rise. No? So, ganun yung ating ganap ha. Bakit uli ganyan yung curve natin? Because this is SASB titration. So, your analyte is the strong acid. So, ibig sabihin yun yung chemical mo to start with. Mababa yung pH niya. Then, as you add your base titrant, the pH will go up. Okay? And in the titration process, we can actually classify them in 4 stages. Okay? So, apat yung stages in the titration process. So that's the initial, the pre-equivalence, equivalence, and the post-equivalence. So let me tell you what's happening for every stages. No? When we say initial, meaning yan, you have not added any titrant yet. Wala ka pang titrant. Okay? Pag sinabing pre-equivalence, you are adding titrant, but the amount of the titrant is not enough to completely neutralize your acid analyte. Okay? So, naglagay ka na ng titrant pero hindi siya enough for you to neutralize your acids. Okay? Your analyte. And then, for the equivalence point, the amount of the titrant you added is just the right amount na to convert all the acids into the products. Okay? So, meaning wala ka ng analyte in the equivalence point. All of them has been converted into your products. Okay? And then at the post-equivalence point, probably nasobrahan ka ng dagdag ng titrant. Okay? So, post-equivalence na yan. Okay? So again, so just to review, okay, at the initial, you have not added any titrant yet. Wala ka pang dinagdag ng titrant. So whatever the pH of the acid is, yun na yun, as is yan. Pre-equivalence, you added titrant, but the amount is not enough to completely neutralize your analyte. At equivalence point, the amount of the titrant is exactly the amount that is needed no, to convert the analyte into the products. So, wala ka ng analyte at the equivalence point kasi lahat sila naging products na. And then at the post-equivalence point, basically, nasobrahan ka na ng titrant. Okay? So, why are the stages important? No? Kasi, as you can see, iba-iba yung chemicals present at each stages, no? So dito, puro acid lang. Dito nabawasan acid mo. Dito wala ka ng acid. Dito sobra na yung titrant. So ibig sabihin, iba-iba yung chemicals, no? Per stages. That's why we have different equations per stages, okay? So pag initial, ito yung equation mo. Pre-equivalence, ito equation mo. Equivalence, ito equation mo. Post-equivalence, ito equation mo. So again, why is that, no? Ganito kasi, sabi ko nga, yung kada stage, iba-iba yung chemicals present, no? Because you added the titrant. Okay? So now, let's go with the initial stage muna. Okay? So, at the initial stage, you only have your analyte. Wala pang titrant. Okay? So, what is in your analyte ba? What's in your Erlenmeyer flask? Okay? So, the chemical that is in your analyte will be the water and the acid. Okay? So, you just have the water and the acid. So, of the two chemicals, which is stronger? Is it the water or is it the acid? Sino yung mas malakas? Okay. Which can influence the pH of the solution. So obviously that will be the acid, no? Kasi yung water, neutral yan eh, 'di ba? Pero yung acid, edi acidic yan. So ibig sabihin, the acid will determine the pH of the solution. Now, how will you get the pH of an acid ba? Oh, you know that strong acids no, tend to dissociate completely. So they will get converted into their products. And in getting the pH, no, what we need is the H plus concentration. Okay? So, ang gusto natin yung H plus concentration. For a strong acid, whatever the concentration of the acid is, yun na rin yung concentration ng H plus and ng kanyang A minus, ng anion niya. So that's why the equation is this one. Okay? So the concentration of the acid is exactly the same as the concentration of hydronium ion. And as you have your hydronium ion, you can get the negative log to get the pH. Okay? So yun yung reason bakit at the initial, this is the equation for the hydronium ion. Kasi we know that strong acids dissociate completely. So meaning whatever the concentration of the acid is, yun na rin yung concentration ng H+. Okay? And then just take the negative log so that you will get the pH. Okay? Now, at the pre-equivalence point, what's happening? Okay? At the pre-equivalence point, you are now adding the titrant. And what happens no, when you add the titrant to your analyte? May chemical reaction. Okay? Sinabi ko to kanina. If you add a base no, sa acid mo, what happens to the acid? Dadami ba yung acid mo or mababawasan siya? So let me repeat. No? Yung titrant mo ay base. So when you add a base to your analyte, the acid, what will happen to the analyte? Will they increase in amount or mababawasan? So the answer is mababawasan sila. Okay? Inulit-ulit ko yan dito. So when you add the base, mababawasan yung acid. Okay? So ganun. So the moles of the acid will decrease. Bakit? Kasi they will form the product. So, ibig sabihin, ito yung mga chemicals natin na present at the pre-equivalence point. You have the water, you have the acid, which is less than the original. Okay, mas onti siya sa original kasi nga nag-react na siya with the titrant. And then the salt, of course. This is the product that I'm mentioning earlier. Okay? Some of the acid has been converted into salt while the others are remaining as is. No? So of the three chemicals, only the acid pa rin will determine the pH of the solution. Okay? Pero nga, nabawasan siya. So, how will you know the amount of the acid that is left? Okay, gano'ng karami na lang yung natirang acid? So, this is the equation that we use. So, let me give you context. Bakit ganyan yung equation na yan? The A stands for the analyte. The T stands for the titrant. Okay? So, what happens ba when you multiply molarity by the volume? So, multiply mo molarity and volume, what you will get? Molarity times the volume will give you letter M. Ano yan? Molarity times volume will give you letter M. Ano yung letter M na yan? 4 letters yan. Molarity times volume will give you M. What's that M? It will give you ayan, MO. Ay, give up na. Sige. It will give you the mole of the substance, di ba? So yan, molarity times volume will give you the moles of your substance. Okay, so that's why, sanabi ko dito kanina, no, na moles yung nababawasan. Okay? Kasi yun yung amount ng substance, diba? Moles is the amount of the substance. Okay? So we need to get the moles of the substances muna na nabawas. So, for you to know how much is remaining, so ilagay mo muna how much you have ba at all, no? So you have your mole acid. Gano'n sila karami? Minus how much titrant was added, no? Okay. So that's the mole base. Okay. Again, yung A mo, analyte acid yon, yung T, titrant base yon. So bakit uli natin sila pinagsusubtract? For us to know how much is left. Okay? The mole acid is the total amount of acid you have. The mole of the base is the amount you reacted with the acid, no? So pag pinag-minus mo sila, you will know how much acid is left. Okay? But since in the pH calculation, we need molarity, not the moles. So since molarity yung gusto natin dyan, we have to divide everything by the volume total. Okay? So the volume total accounts also for the dilution. Okay? Kasi it is the sum of the volume of the analyte and the titrant. Okay? So ito yung reason why the equation is like this, no? Okay, so and I hope na nabigyan siya ng justice sa laboratory. Okay. So yun, kasi nauna kayo dun sa discussion niya, probably. Okay. So the reason behind this equation is that it will actually let you know how much is left. Okay. And for you to know how much is left, you just subtract the amount of the base you added sa acid. But since we need concentration in molarity, this moles has to be divided by the total volume so that you can get molarity ulit. Okay? So yan. So that's the reason behind this equation. Okay? So it's MAVA minus MTVT over V total. And now, at equivalence point, what did I say? At equivalence point, all your analyte has been converted into products. And again, for neutralization reaction, the products are water and the salt. Okay? So, kaya nawala na yung HA. Wala ka ng acid. Okay? Kasi naging product na siya, which is the salt and the water. So, of the two chemicals, which will influence the pH of the solution? So, obviously, yung water. Kasi yung salt, wala namang pH yan masyado. Okay? So, yung water yung may effect. And what's the pH of water? We know that the pH of water is 7. Okay? Paano naging pH 7 yan? Okay, because it has something to do with the acid-base property of water. If you can recall your laboratory discussion on that, so you know that water dissociates into H plus and OH at equal amounts, no? So mag-ice table ka dyan. Okay? So yan, 0, 0. Yung water, wala dyan ilalagay. So that is described by Kw, H plus, and then OH minus, na? And since the dissociation of water produces equal amount of H and OH, so we can just simply combine them, okay? And then getting the square root will give you the concentration of the K double of the H plus, okay? So doon yan ang galing sa ionization of water, okay? And what's the square root of Kw? So that's 1 times 10 raised to negative 7. If you take the negative logarithm, that will give you 7. Okay? So that's why the pH of water is always 7. So ibig sabihin at equivalence point for SASB, the answer is always 7. 7 talaga siya parate. And the next one, at post-equivalence point, ano nangyayari dito? You added too much titrant na. So you actually have 3 chemicals in your flask. your water, the salt, and the excess base. So of the three, the excess base will influence the pH of the solution. Kasi siya yung stronger eh. Strong base tayo, remember. Okay? So the strong base will determine the pH of the solution, the excess base. How will you know the excess, no? So for you to know the excess amount of the base, so basically that's MTVT minus MAVA. Again, multiplying the molarity by the volume will give you the mole. So this equation just tells you that the mole of the base, okay, must be deducted with the mole of the acid, no? Okay? So yung sobrang base, isusubtract mo sa kung gaano karami yung nag-react sa acid. Okay? So that's why the equation is that. So mole of the base minus the mole of the acid, or molarity titrant, volume titrant minus the molarity of the acid, volume acid. Okay? Kasi pag pinag-subtract mo sila, malalaman mo ilan na lang yung natitira. No? Ilan yung excess na base. Okay? Similar with the previous one. And since we need molarity concentration, we have to divide this by the total volume. Also, take note, no? Ito yung sinasabi ko na maraming nagkamali last year. Yung OH, if you take the negative log of it, you will get the POH, not the pH. But usually, what we're looking for is the pH. So, you have to convert the POH into pH pa. So, kailangan all of those must be remembered, no? Yung process ng pag-convert, no? So, just take the negative log and then you'll get the POH. If you want to get the pH, so you subtract the POH from 14. Okay, so that's 14 minus POH. Okay? Doon marami nagkamali sa class ko dati. Hindi ko kasi ni-reiterate. Pero syempre, you have to be careful din, no? Okay. So, yun. Okay lang. Tanggap naman nila na doon sila nagkamali. Okay. Kasi sabi ko naman doon sa kanila, i-convert nyo to pH. Pero hindi ko lang inulit-ulit. Kaya siguro nakaligtaan nila. Okay? So, sayang naman yung points. So, instead of you having 4 points, naging 3 points na lang na. Also, wala magkakamali at equivalence point, ha? The pH at equivalence point for SASB titration is always 7. Pag may nagkamali dyan, minus 10. Joke lang. Okay. So, eto, parang bonus na yan. 7 talaga yan, no? Whatever happens, as long as it is SASB titration, it will always be 7. And then again, for the post-equivalence for SASB, you will actually get the POH muna before you get the pH. So, you have to be careful with those minor details that can actually have huge implications to your answer. Okay? Just to summarize the equations needed for the SASB titration. Okay. So, the amount of the acid at the initial stage is just whatever the concentration of the acid is, no? So, kunwari, sinabi, 0.1 molar HCl. Edi yun na yung concentration ng H plus mo. Okay? So, ganun ha. So, whatever the concentration that is reported, yun yung H plus mo na. And you know, at pre-equivalence point, you are now adding the titrant. So, nababawasan na yung H plus. So, for you to determine how much H plus is left, we use the equation MAVA minus MTVT over the V total. Okay? So, I hope yung derivation na didiscuss sa inyo ni lab na. I don't know kasi kung sino yung mga lab niya. Okay? So, I hope na nakakwento din. Bakit naging ganyan yung equation? Okay? Kasi ako talaga ina-explain ko sa aking lab discussion. Kaya nabot kami ng 2 araw para lang sa monoprotic. If you want to watch, I can give you a copy na. So, yan. Okay? So, may reason behind the equations na. Okay, so for the pre-equivalence point, you need to determine how much acid is left. So the equation there is MAVA minus MTVT over the V total. Again, MAVA refers to the analyte, which is a strong acid. The MTVT refers to the titrant, which is the strong base. So if you subtract them, you will get how much acid is left. And we have to divide it by the total volume because we want molarity. At equivalence point, you don't have any analyte anymore. All of them has been converted into salt and water. And the pH of the water is always 7. Okay? So how was it obtained? So you can just simply write H plus equals the square root of the ion product of water. So at the post-equivalence point naman, you have excess titrant. Okay? So to determine how much titrant is excess, no? The equation there is MTVT minus MAVA over V total. Okay? So this is the mole of the base titrant minus the mole of the acid that reacted with the base. So if you subtract them, makuha mo yung sobrang acid na. Sobrang base. Then divided by the total volume to convert it into molarity. And as you take the negative log of it, wag kakalimutan, kasi kinalimutan to last year. So yung OH, magiging POH yan if you take the negative log. What we want is the pH. So, ko-convert mo pa siya into pH. Okay? So, yan yung equation per stages. You can take screenshot. Okay? Pero I hope you can still remember what was discussed in your laboratory. Okay? Birthday ng teacher ko. Okay. Alam niyo yun sa high school, may mga favorite teacher ka talaga. Okay. Ayan. Birthday niya pala. Greet ko na lang later. Okay. So, ayan. So those are the 4 stages and the 4 equations. Okay? So as you can see, no, may reason pala behind the equation. No? Hindi lang siya as is na, basta yan, gamitin yan. No? So may reason. Ano yung reason natin? The species present. Okay? This tells us what equation should be used. Okay? Because depending on which is dominant among these species, no, will actually help you know what equation is proper, no? So, yan. Okay? So, I know nakapag-answer na kayo ng problem na to, but let us repeat lang uli, no? Okay. So, let me just repeat this problem if you already answered this in the lab. So, just to reiterate lang kung ano yung mga natutunan niya sa lab. Okay? So, do the calculations needed to generate the hypothetical titration curve for the titration of 50 ml of 0.05 molar HCl with 0.1 molar NaO. So, kung ano yung sinabi at first, that will be your analyte. Always remember that. Kung sino yung binanggit muna, siya yung analyte. Ganun kasi yung chem, may mga patterns. So, this is your analyte. And whatever is mentioned next, yun yung titrant mo. Now, we have to classify what is our analyte. So, HCl, as you know it, is a strong acid. Okay? Sodium hydroxide, you already know it's a strong base. Okay? So, it's a strong base. So, anong titration meron ka? SA, SB. Okay? So, ganun. So, parati nyo to gagawin at first kasi baka mamaya weak acid pala yan, no? O ibang equation gagamitin mo doon. Mamaya, strong base, strong acid pala, no? O ibang equation uli gagamitin mo doon. Okay? So, kailangan you check first. What are the given analyte and the titrant? Are they strong or weak? And from that, you can identify what type of monoprotic acid-base titration you're doing. Because again, keep in mind, iba-iba ng equation per category. Okay? So, if you use the wrong equation, mali na lahat. So, sayang effort. Okay? So, after identifying na ito ay SASB, So, you know na ito yung equations mo. Okay? So, sa quiz, ganun gagawin nyo. So, alamin nyo muna anong type of titration ba to? SASB. So, susunod yung gagawin is hindi tumingin sa Cheng, no? Alam ko nag-cheng yung iba sa inyo. Okay. So, gagawin nyo, pagka-identify nyo kung anong type ng titration meron ka, you look into your kodigo ng equations. That's fine naman. Okay. So, okay lang gumawa ng kodigo kayo. That's why I'm telling you kanina to take a screenshot of this one. Okay. Para pag nag-quiz kayo, tignan nyo na lang ano yung equation na sinulat ni sir. Okay. Kasi, kapag chemistry ka, kakabisaduhin mo yan. That's why kabisado ko siya. Pero kapag di ka naman chemistry, hindi naman kailangan na. Okay? So, screenshot nyo na lang, then balikan nyo na lang. Okay? Pakita ko lang yung mga pinagkakabisado namin sa chem. Madadaanan natin to. Ganyan. Dami namin kinakabisado sa buhay. Required kasi chemist kami. Sa inyo, hindi na. Okay? Okay, so after identifying that this is SASB, then you have to know the equations that are useful in answering the problem. Pero what will be our next problem dito? Look at the volume of the titrant. So the volume of the titrant, iba-iba siya, no? So may 0, may 10, may 25, may 25.1. So the question is, anong stages sila? Kasi at each stage, you have different equations, right? So, asan yung 10 ml? Nasa initial ba yun? Nasa equivalence ba yun? Nasa post ba yun? Nasa pre ba yun? I don't know, di ba? So, asan yung 25 dito? Is it the initial, pre, equivalence, or post? What's 25.1? Pre-equivalence ba siya? I don't know, di ba? Especially, kunwari, ganito yung problem mo. Ayan, ang daming volume ng titrant. Anong stage yan? I don't know, di ba? So if that's the case, no, you have different volumes, then you have to label them according to the stage. Anong stage ba sila? Okay? So to help you identifying the stages of the volume of the titrant, I want you to look for our best friend. Tawag ko dun is si VTEP. You have to find for the VTEP first. What's the VTEP? That's the volume of titrant at equivalence point. So I think amount of the titrant needed to reach the equivalence point. And ano sabi ko kanina in the previous slide? Yung equivalence point, may equation na tayo dyan, no? Ito na yun. Okay? Na-delete ko pa. So ito na yung equation natin at equivalence point, right? So ito gagamitin natin to get the VTEP. Okay? So at equivalence point, what we know is that the mole of the analyte is the same as the mole of the titrant. Okay? And the stoichiometric ratio is 1 to 1. Why is it 1 to 1? Kasi nga, this is monoprotic. So 1 to 1 lang yung ratio nila. Okay, so mole of the analyte is equal to the mole of the titrant at equivalence point. And how do you get the moles? That's molarity times volume lang. Okay? And ano yung uli yung VTEP? What does it stand for? The volume of the titrant at equivalence point. So basically, ito yon, right? So this is the VT. So to get the VT, the volume of the titrant at equivalence point, so that will just be MAVA minus MT, no? Yan. So you can actually save this equation. And then you can just plug in whatever is given. So for the analyte, what's the molarity? Ito. So 0.05 molar. For the volume, that's 50 ml. And then for the molarity of the titrant, ito yon. Okay, oopsie. Yan, so ito yon, so 0.1. Okay, so ganun lang. So again, bakit ba natin uli sinosolve si VTEP? So we need to look for the VTEP so that we will know what stage are we in. Okay, kasi tandaan nyo, iba-iba yung volumes na yan. And for every volume, we could fall in one of these four stages, no? And this is very crucial kasi kapag nagkamali ka ng stage, mali yung sagot mo. Right? So you have to solve for the VTEP first, no? The volume, the titrant at equivalence point. If you know the equivalence point, then you can assign the other stages na lang. Okay? So if you do this calculation, so that's MAVA over MT, that will give you 25 ml. By the way, yung volume na ml, wag nyo na i-convert into liters, na. So as is na sila. So 25 ml is our VTEP, or the volume of titrant at equivalence point. Meaning that 25 ml is the equivalence stage, no? So ito yung equivalence stage natin. So kung sa graph yan, ito yon. Oopsie. Ay, ano ba yan? Yan. So ito yung 25 ml. So any volume less than 25 will fall under pre-equivalence, and any volume greater than 25 will fall under post-equivalence. Okay? So ganun ka-important yung VTEP because you can then assign the stages. Okay? So 25.1 is greater than 25, no? So this is post-equivalence. 10 ml is less than 25, no? So it is pre-equivalence, no? And yung 0, automatically initial yan. Kasi you did not added any titrant yet, no? So initial yung 0. Okay. So keep this in mind, ha? Ito, nare-reiterate ko ulit para alam nyo kung paano mag-solve, no? Not because you have the equations, meaning as is na plug in na lang. No. You have to identify first which stage are you in, because the stage, will actually help you to get the correct answer. If you are in the wrong stage, then you will get the wrong answer. So that's why you need to look first for the VTEP. Ito lang yung equation doon, so you can save it na. Okay, ulit-ulit lang yan. So that's the equation, and once you identify the VTEP, then you can assign different stages na. So any volume less than that will be pre, any volume greater than that will be post. And then yung 0, initial talaga yan. Okay? So tandaan nyo yan, ha? So in the laboratory, i-discuss naman yan na mas mahaba na. So you have plenty of time in the lab. Sa lecture, puro reminders lang gagawin ko sa inyo. Okay? So yan. So once you identify the stages, now you can proceed with the pH calculation. Okay? And remember, for each stages, iba-iba yung equation. So I'm going to write the equations muna, no? For the initial, that is the concentration of your acid. For the pre-equivalence point, that is how much is left. Okay? So the equation is MAVA minus MT VT all over V total. At equivalence point, ang equation natin ay square root of KW lang. And then at the post-equivalence point, ito yung equation. Okay? So it is MT VT minus MAVA over V total. So ganito gagawin niyo muna. Okay? So you know that for each stages, you have different equation. Okay? So lagay mo na yung equations mo. No need to memorize. Okay? Just save your brain cells for more important topics. Okay? So doon na lang yung inyong brain space na. Kasi dito pwede naman tumingin sa kodigo. Kasi remember, more than 16 yung equations natin. So, wag nyo nakabisaduhin. Okay, so for the initial, so according to the initial, the concentration of the H plus, which will be needed for the pH calculation, is whatever the molarity of the acid is. No? According to the given, the concentration of the acid is 0.05. So, yun na yun. Okay? So, that's it. Okay? Ganun lang ka-simple. So, to get the pH, so you just take the negative log of the concentration of the acid, no? So, that's negative log 0.05. So, ang sagot mo, 1.30. Okay? So, ganun lang ka-simple. So, 1.30. Oh, now, at the pre-equivalence point naman tayo. So, in the pre-equivalence point, all we need to do is to substitute the values. Okay? The molarity and the volume of the analyte are this. The molarity of the titrant, volume of the titrant are this. Ayan. And the volume total is just the sum of the volume of the analyte and the volume of the titrant. No? Okay? So, magpa-plug in ka na lang. So, what's the molarity of the analyte? So, it is 0.05. Oh, what's the volume of the analyte? So, that's 50 ml. Again, no need to convert the ml into liters. No need na. For the molarity of the titrant, it is 0.1 molar. For the volume of the titrant, it is 10 ml. And for the total volume, so that's just the volume of the analyte and the volume of the titrant. So 50 plus 10. Okay? So ganun lang ka-simple. Magpa-plug in ka lang talaga. And then with that, let's solve for the concentration of H plus. So, ito yun. So, 0.05 times 50 plus 0.1 times 10. Divided by 50 plus 10. Teka lang. 0.05 times 50 plus 0.1 times 10. 50 plus 10. Parang may something off dito. Ang naalala ko kasi 0.025 eh. Okay. Naka-plus pala. Ayun. Diba? Sabi ko na parang may off eh. Ilang araw ko na ginagawa to. So, 0.05 times 50 minus pala. 0.1 times 10 plus over 50 plus 10. Okay. Yan. Ayun. So, lumabas na yung 0.025. Okay. So, this is the amount of the acid that is remaining na, no? Okay. So, again, you have to be very careful kasi even ako minsan nagduling din ako sa science. Okay. So, yan. So, that's the concentration of the acid that is remaining. So, to get the pH, all you have to do is to take the negative log. Okay? So, to take the negative log of the answer, you get 1.60. Okay? So, it's 1.60. Now, at the equivalence point, this is no-brainer. The answer is 7. Okay? 7 talaga yan agad. Okay? Kasi sabi ko nga, the pH of water is 7. Okay? Yan. Water lang kasi nandun. 7 yan. Pag kayo nagkamali dyan, minus 100. Mag-iingat dyan ha. Wala naman ako na-encounter so far na nagkamali dyan. Siyempre, 7 na nga eh. Ang sagot eh. Okay? Now at the post equivalence, so nagkabaliktad lang, MTVT minus MAVA over V total. So this is the molarity of the titrant, so 0.1. The volume of the titrant is 25.1. Okay. For the molarity of the analyte, so that's still the same, 0.05 times the volume of the analyte, which is 50 ml. For the total volume, so you just add the volume of the analyte and the volume of the titrant. Okay, so that will just be 50 plus 25.1. Okay, so let's use the calculator. Solve natin siya. So 0.1 times 25.1 minus 0.05 times 50 divided by 50 plus 25.1. So what is this? This is the concentration of the OH. If you take the negative log of this, what will you get? The POH, na? Hindi yan yung sagot kasi POH yan eh. Okay, tandaan nyo yan. Pag kinuha nyo negative log ng OH, you're not getting the pH. Instead, you're getting the POH. Since we are looking for the pH, we have to subtract this from 14. So 14 minus that, that's the pH. Okay? So, walang magkakamali dyan ha. So, I'm reiterating this kasi last year, may mga nagkamali dyan. Sayang naman. Okay? So, it's 10.12. Ayan. So, ganun lang. Okay? So, that's how you determine the pH. So, again, first thing you have to do is to identify what type of titration you have. So, it actually depends on the identity of your acid and the base. Then, once you identified it correctly, then you can use the set of the equation that is appropriate to that type. Okay? Such as this thing here. Okay? And then, kapag na-identify mo na what type of titration and what equations you will use, you have to identify the stages. Okay, iba-iba yung stages per volume. So, hanapin mo muna si VTEP, okay, or the volume titrant at equivalence point. Then, once you get it, you can then assign the stages, and for each stage, you have different equation. Okay, you just copy whatever is written here. Lagay mo lang siya dyan, and then you substitute the values. Okay. Be careful with the OH because if you take the negative log of that, that's not the answer yet. You have to subtract it from 14 so you can get the pH. Okay? So, ulit-ulit na ako dyan. Kaya, dapat walang magkamali. Okay? So, yan. So, for the titration curve, actually, ito yung magiging problem set ninyo. Pero, we'll give more details na lang after the midterms na lang, na. Tutuloy pa naman natin to sa April. So for the titration curve, again, the vertical axis is the pH, no? So yung pH mo yung nasa vertical axis. And in the horizontal axis, what you have here is the titrant volume. Okay? So you label the graph accordingly. Be consistent with your gaps, okay? With your intervals. Ayan. So at 0 ml, we have 1.3 na pH. Ayan yon. So at 10 ml, it became 1.6. Okay. Somewhere here. So at pH 7, so 25 yon. So 7, 25. And then 25.1, it's 10.12. Okay. So if we graph that, it should look like this, no? So pag graph yan, ganito dapat itsura. Okay, may curve. Then near the 7, magaganito kayo. Okay? Biglang magiging steep yung slope niya. Tawag doon inflection point. So, tawag dyan inflection. And in the inflection curve, andyan yung endpoint, which is 25 ml. Okay? So, para siyang pa letter S talaga. Okay? To give you an idea kung ano itsura ng inyong problem set, okay, so ganito yung gagawin niya sa problem set. It's still loading. Asan na ba yan? Ayan yung mga chinikan ko sa inyo kahapon. Okay, so this one. Okay, so ganito gagawin yan in your problem set. I'll give you a problem and then you'll create a titration curve using Excel. Okay. So as you can see, this is strong acid, strong base titration curve. You begin with the low pH and then suddenly, aangat siya. And then you will have the inflection curve. And then magpa-plateau siya. Okay? So ganun siya. So mababa pH, aangat onte, then slope, and then plateau. Okay? So ayan. So, ganun din for the other types of titration. No? So, siguro I'll teach you na lang on how to do them. Okay? So, gagawa na lang ako ng video about it for your problem set. Okay? So, ganun lang. We will proceed with the next one. So, that's, ito yung sagot natin. Ito, sa lab, nasagutan na to siguro, no? Okay. Pero kung pag di pa nasagutan, then I can give you my recording sa lab. Okay. Medyo matagal yung kasi dinidiscuss ko talaga bakit ganun yung equation. Okay. So, yan. I'll skip that one kasi sa lab sasagutan yan eh. And now, let's proceed with a strong base, strong acid titration. So, at this time, nagkabaliktad naman. Okay. The analyte is the strong base and the titrant is the strong acid. Okay. So since base yung inyong analyte, what do you think will be the initial pH? Is it higher than 7 or lower than 7? Your analyte is a base, so what's the initial pH? Is it higher than 7 or lower than 7? What do you think? Higher than 7. Okay, kasi base nga eh, di ba? Okay, so you will begin with a very high pH, and then upon the addition of the acid titrant, it will fall down. And it actually looks like this. Na? Parang binaliktad lang siya na SASB. Diba sa SASB, you begin with a low pH, and then it will go up like that. For SBSA, baliktad naman. So you begin with the high pH, and then it will go down, okay, in the same manner as SASB. Also, there are still 4 stages, no? Basta pag monoprotic titration, 4 yung stages talaga. Okay? So, the 4 stages are initial, pre-equivalence, equivalence, and the post. So, same concept lang din. At the initial, you have not added any titrant yet. At the pre-equivalence point, you added titrant, pero they are not enough to convert your analyte into the products. At the equivalence point, you don't have any analyte anymore. Okay, so all of them has been converted into the product. And then for the post-equivalence, wala ka ng, sobra na yung titrant mo. In our case, strong acid. Okay. Just like earlier, ganun din yung pH calculation. It depends on the chemicals that are present in your sample. For initial, you only have water and the base. Okay. And yung base natin yung magdetermine ng pH ng solution. Okay, so it is the base that will determine the pH of the solution. So since this is a strong base, no? Yung ating base na MOH, M is the metal, and then the OH is the hydroxide. So since this is strong base, we know that it will fully dissociate into the metal cation and the OH concentration. So meaning, whatever the concentration of this one, okay, so whatever the concentration of this one is, yun na rin yung concentration ng OH natin. So that's why ganyan yung equation natin. So that is determined by stoichiometry. Whatever the concentration of the base is, yun na yung concentration ng OH. Parang yun sa acid lang din kanina. Okay? And then, at the pre-equivalence point, you are now adding the titrant. So, ano nangyayari sa base? Yung ating base, pag naglagay na tayo ng strong acid, no? Let's say HA, magpo-form na yan ng water and ng salt, no? Ayan. So, metal and the anion. So, magpo-form na yan ng water and the salt. But, the amount is not enough, no? So, ibig sabihin, may salt kang mapo-form, pero may base ka pa rin. Kasi nga, not enough yung amount ng titrant at pre-equivalence point. So, of the three chemicals present, yung base pa rin yung magdidictate ng pH ng solution, right? However, the amount of the base is less than the original. So, paano uli kinukuha kapag less than the original? So, it's MAVA minus MTVT over the V total. So, this time it's the moles of the base minus the mole of the acid na you added. Kasi sabi nga natin kanina, when you add an acid, the moles of the base decreases. So, ito yun, in equation. And since we want to solve for pH, ibig sabihin, kailangan molarity yan. So, you just divide it by the total volume. Okay? So, yun yung reason behind this equation. And then, at equivalence point, all of this are gone. Wala ka ng analyte. So, basically, na-convert na sila into water and the salt. Okay? Wala ka ng base. And of the two chemicals, water will determine the pH of the solution. And what's the pH of water? 7. So, walang magkakamali dito kasi it is always 7 for SASB and SBSA. Okay? So, parehas siyang 7 for both cases. And then lastly, just like kanina lang din, at post-equivalence point, you have added excess amount of the titrant. Okay? So, tatlo chemicals mo, the salt, the water, and the excess acid. So, kung sino yung stronger, siya yung magdidictate ng pH, which is, of course, the excess acid. And how do we get the excess acid? Ito yung equation. So, MTVT minus MAVA over V total. So, what's the rationale behind this equation? So, it is just the mole of the base minus the mole of the acid. In this way, we can get how much base is in excess. No? Because we know some of them reacted with the acid. So, if we negate that, malalaman natin kung gaano karami yung excess. Okay? And since we're looking for the pH, we want molarities, so we have to divide it by the total volume. Okay? So, same lang ng logic with kanina. But this time, it is the base, yung ating initial. Okay? And yung excess natin ay yung acid. Okay, again, no need to remember everything. Basta alam nyo saan sila nanggaling. Ayan yan. Kasi most likely, the problems in the lecture will be conceptual. Like, bakit naging ganyan yung equation? Bakit naging ganito? So, that is what you're going to expect. No? And upcoming quiz. Pero matagal pa yan. April pa. Okay. So, to summarize, I'll write everything here in the graph para alam nyo kung ano gagawin niya. So, at the initial stage, whatever the concentration of the base is, yun yung OH mo. And do not forget, yung OH, if you take the negative log, it becomes POH. And then that POH needs to be converted into pH. Okay? At pre-equivalence point, nababawasan na yung base mo. So, to get the amount of the base left, so it is MAVA minus MTVT over V total. Okay? So, just like kanina. But this time, you're actually solving for the OH. At equivalence point, wala ka ng base. So, you just have water and the salt. So, the pH of water is 7. Okay? So, walang magkakamali dyan. And then at the post-equivalence, you added too much acid na. So, to determine how much acid is in excess, so, same lang din kanina. So, it will be MTVT minus MAVA over the V total. Okay? So, ganun lang. So, another set of 4 equations. Marami pa tayong makikitang equations in the future. Okay? So, you can take a screenshot, pero if you have one already, then that's good. Okay? O, tandaan ha, na the equations that you're going to use depends on what type of titration you are doing. Okay? So, you really have to be careful. By the way, share ko lang kasi nag-notify yung GCash. Since may pandemic pa rin, naman, promote ko na lang. Although, wala namang, Kasi meron ako ditong, yung G-Insure. Okay. So, G-Insure is, yung parang insurance ng GCash. I have plenty of insurance actually. 5 ata. Anyway. So, nung ako nagka-COVID, nung January 5, until January 20, COVID period ko yun eh. So, ginamit ko yung G-Insure to reimburse my testing cost. So, yan. Kasi 'di ba when you take the RT-PCR sa Red Cross, it's 1.5. So, i-reimburse nila yung 1.5. If you get hospitalized, they can also reimburse it. So, ang binayad ko lang noon, 700. So, bali, binayad nila sa akin 1.5. So, nakakuha pa ako ng 800 more than what I gave. No? So, that's how insurance works. Anyway, hindi naman ako FA. Try nyo lang yun sa GCash. Na. Ang daming features ng GCash na I really like. Na. And according nga sa friend ko na FA, yung GCash daw, it can handle trillions of pesos na transaction during COVID, no? At the height of the COVID pandemic sa atin. Imagine yung trillion pesos pala yung dumadaan sa GCash. Galing. So, the future is digital banking talaga. Kaya nauuso yung mga NFT, crypto, digital banking. No? Hindi na uso yung pera-pera na. Yung papel. Anyway, going back. So, let's answer this last problem. I know you answered this already in the laboratory, but just for the sake of reiteration, ulitin natin siya. Okay? So, this is the problem. Calculate the pH during the titration of 50 ml of 0.05 molar NaO with 0.1 molar HCl after the addition of the following volumes of reagent. So, katulad ng sinasabi ko earlier, whichever was stated first, it is your analyte. Okay? So, this is your analyte. And this one is your titrant. Okay? Ngayon, you have to look at the identity of your analyte. So the analyte is sodium hydroxide, and you know that sodium hydroxide is a strong base. Your titrant is HCl, which you know is strong acid. So what type of titration you have? SB, SA. So, yun. Pasok siya dyan. And if you have SB, SA titration, these are the equation that you're going to employ. So, ganun lang, kasimple na. Kung sino na una sinabi, siya yung analyte. Kung sino sumunod, siya yung titrant. Identify whether they are strong or weak. And then, it depends kung anong equation yung meron for that type of titration. Okay? Now, I know the type of titration and the equations I'm going to use. But the next problem is I don't know the volumes. No? What are these? No? Ito ba initial? Ito ba pre-equivalence? Ito ba equivalence? I don't know. So, ano gagawin mo? Solve for the VTEP. Okay? Find the volume of titrant at equivalence point. And may equation na tayo dyan kanina, right? So, that's VT equals MAVA over molarity titrant. So, kabisaduhin nyo na lang yung equation. So, MAVA, so this is your analyte. So, 0.05 molar times 50 ml divided by 0.1 molar. So, actually, same lang to kanina. So, it's still 25 ml. Okay? If you calculate it. Okay? So, that's our VTEP. So, since this is our VTEP, meaning this is the equivalence point, okay? Any volume less than that is pre-equivalence. So, meaning itong 24.5, that's pre-equivalence point, and the 25.5 will be the post-equivalence point. Okay? So, ganun lang. And then, you know, iba-iba yung equation kada stage. So, I'll just copy them. And then later, I'll just substitute the numbers. Okay? So, at the pre-equivalence point, that's the amount of the base that is left. Okay? So, it is MAVA minus MTVT over the V total. Okay, at equivalence point, that is the same as the SASB titration, so it's just the square root of KW. And at the post-equivalence point, you have the excess acid. So the equation there is MTVT minus MAVA over the V total. Okay? Ganun lang. Then, you can start substituting the terms. Yung MAVA, ito lang yon. Ulit-ulit lang yan. Okay, so that's 50 ml and 0.05 molar. So, ulit-ulit lang yan. For the molarity titrant, ayun yon, 0.1. And then the volume of the titrant, it will be given. Kung hindi nasa table, nakalista yan. Okay, so it's 24.5. And the volume total, edi of course, you add the two volumes. So 50 ml analyte, 24.5 ml titrant. So you will get the OH na. Okay? So for the OH is 0.05 times 50 minus 0.1 times 24.5 divided by 50 plus 24.5. So ito yung ating OH concentration. So get the negative log of that. This is the POH. Hindi yan yung gusto natin. We want the pH. So that will be 14 minus the POH. So 10.83. By the way, 2 decimal places parate, ha? Okay. So the POH is 10.83. Ano uli ginawa ko? So OH to POH, kunin mo lang negative log. And then from POH to pH, that will just be 14 minus the POH. Okay? So answer is 10.83. At equivalence point, walang magkakamali dito. 7 yan. Okay. And then lastly, for the post-equivalence point, you have an excess amount of the titrant. Okay. So, ano lang yan? MTBT. So, substitute lang yan, no? Yan. Okay. So, molarity titrant is 0.1 molar times 25.5. Okay. Then, for the analyte, ulit-ulit lang yan. So, it will be 0.05 times 50. And then, for the total volume, so you have 50 analyte plus 25.5 titrant. Okay. Okay, so it will be 0.1 times 25.5 minus 0.05 times 50. Sorry. 50 plus 25.5. So this is the concentration of your acid, excess acid. If you take the negative log, that's the pH na. So yan na yung pH niya. So 3.18. May student ako last year. Last year kasi yung first SEM na full online yung Anachem eh. Okay. Kaya medyo ang dami nag-a-adjust pa. Na last year nangyari naman, eto, minus 14 niya. 14 minus this. Mali yun. Okay. Okay. So mag-ingat ha. Kapag OH, doon ka lang maggagamit ng 14 minus POH. Pero kapag H plus na yan, no need na. Just be careful lang. Okay? Ako kasi nangihinayang sa score niya. Ano na. Okay. So yan. So that's how you do titrations. No? So again, yung ating equation, they have derivation. No? So may logic behind those equation. Basically, those equation are just obtained depending on the species present. No? So in your laboratory, no? Kasi mas maraming time doon, so doon kayo makakapagsagot talaga ng mas mahaba. No? So in your laboratory, I hope na ma-discuss yung concept behind these equations. No? Although, kasi madadaanan natin yung by April pa eh. Okay? Pero I'll give you an idea na lang. Okay? So, weak acid kasi to, no? So, that's why we need to use the square root of Chaka, no? As you know it. Instead of using istable, wag na, no? So, use shortcut na lang. Okay? So, yun. Anyway, so, discuss na lang natin to sa April. Kasi limited yung time natin. For weak base, ganun din. It needs to employ equilibrium equation and of course the Henderson-Hasselbalch equations. Okay? Ayan. Also, sa April na meeting natin, we'll cover polyprotic and ganito karami yung kaganapan sa kanilang life. Yan, bulaga. Yan. Pero anyway, hindi naman natin siya in-depth discussion, no? So, as is na lang siya na derivation. Okay? So, anyway, we will have 2 problems about it next April. So, sa kanya na muna to problemahan atong chapter na to, na? Kasi all you need to focus on is the chapters 1 to 4. Okay? Kasi yun yung nasa midterms. Again, just to, repeat what I said earlier, if you miss the quizzes, I'll create another schedule next week. Okay, so gagawa na lang ako ng schedule next week. Ayun. And then magpo-post ako ng solution sa lahat ng problem solving sa quiz. If not mamaya, baka bukas. Kasi I am yet to finish the calculation. Dami kasi. Okay, tapos ipo-post ko na lang for everyone to review. Okay, so kung hindi ko ma-post mamaya, so baka tomorrow ko siya ma-post. And then, submit your prob sets tomorrow. They are all due by tomorrow. Actually, yung problem set ko nga, binonus 1 ko na yan. Yung problem set 1, binonus ko na for everyone. Kasi okay naman yung mga gawa niya. Okay? So, pinerfect ko na lang. Okay? But for problem set 2, 3, 4, yung mga calculation, if you submit it by Saturday, then probably masasend ko rin yung answer sa kanila the day after, no? So sa Sunday, para may additional reviewer kayo lalo. Okay? So ganun. So yun lang muna, no? So I hope na yung mga materials na ibibigay ko, if not today, tomorrow, hopefully makatulong yun, na. So I am yet to finish the solution manual kasi ang daming problem pala. Okay? So don't worry, ako na bahala sa inyo doon. Okay? And then do not forget the prob set, na until tomorrow na lang siya because we extended a lot of times na. Okay? Masyado na siya na-extend. Okay? So if you want a copy of the question for problem set 4, you can ask me naman. Okay? So yun. So that will be all for our session today. So I'll see you again next time. Okay? So sa April 8 yung next meeting natin. Because next week ay midterms. Next week ay consultation. Probably either March 31 or April 1 ako magpo-post ng grades na. And then April 4 back to school ulit tayo. Okay? So I'll see you na lang next time. So good luck and galingan, okay? So yun. So I'll see you again and bye-bye.